Hi everyone, and welcome to this video going over lesson 35.1, surface area of pyramids and cones. This is our first video interacting with pyramids and cones. They are different from prisms because they only have one base. So we are going to see how finding lateral area and surface area might look a little differently for pyramids and cones. So we are going to start off by looking at a cone. A cone has a circular base and comes to a point. And in order to start looking at lateral area and surface area, I need to examine the net, which means if I were to flatten out this cone, what would it look like? And so we would have our circular base, and then the top part is a section of a circle that almost looks like a Pac-Man. Notice how it's not a complete circle. It's known as a sector of a circle. And remember, lateral area is just the area of the lateral faces. So because for a cone, this is the only lateral face, in order to find the lateral area, we need to find the area of this sector. And so the formula to find the lateral area of a cone is pi times the radius of the base times L. And L stands for the slant height. Notice this slanted height measure of this cone is going to match up with this measure here once the cone is flattened out. We call that length L, and that is our slant height. And this is the formula to finding the area of that sector of the circle. To find surface area, we are going to take our lateral area, so the pi times radius times the slant height, and we add the area of the base that we excluded from lateral area. And for a cone, since the base is a circle, to find the area of a circle, we use the formula pi r squared. So the same idea applies for prisms and pyramids. That lateral area is the area of everything except the bases, and surface area is the area of everything including the bases. So let's give this a try. To find lateral area, I'm going to multiply pi times the radius times the slant height. My radius is 4 and my slant height is 6. So this will look like pi times 4 times 6, which will give me 24 pi inches squared. Then to find surface area, I'm going to add my lateral area to the area of the base, which means I first have to find the area of the base, which I will do by using pi r squared because my base is a circle, and the radius is 4. 4 squared is 16, so I will be adding 16 pi to my lateral area. And this gives me a surface area of 40 pi inches squared. Let's try this again. I have another cone, and to find lateral area, I use the formula pi times radius times the slant height. The radius is 10, and the slant height is 12. So I have pi times 10 times 12, which gives me a lateral area of 120 pi inches squared. Then to find surface area, I have to start by finding the area of my base, which I will use pi r squared for. So pi times 10 squared, which gives me an area of my base of 100 pi inches squared. Then to find surface area, I just have to add this to my lateral area. So 120 pi plus 100 pi gives me a surface area of 220 pi inches squared. And that is how we find lateral area and surface area of cones. Let's move on to start talking about pyramids. A pyramid is a 3D solid with one polygonal base whose lateral faces are triangles with a common vertex. So notice how this is different than a prism because I only have one base and all my lateral faces are triangles that come to a point at the top. So let's go over some vocabulary. Inside you'll see a height line that we call H. This represents the height of the pyramid. So this is what we would use for volume. But then notice how I have another height, and that is L. Remember, we call that our slant height. And this is important because our slant height tells us the height of our lateral face. So when we go to find the area of our lateral faces for lateral and surface area, we are going to use our slant height L for the height of each triangle. And then S we call our base edge, because when I use the word base, I'm most often talking to the entire polygon that makes up our base. So when I refer to this length, I will say base edge. Moving on, pyramids are also similar to prisms in that we name pyramids based off the shape of their base. So in A, it looks like I have a square base. So this is a square pyramid. And in order to draw the net of each pyramid, we draw the base in the middle. So I would draw my square, and then each base edge gets a triangle. Let's try this again. In B, it looks like the shape of my base is a pentagon. So this is a pentagonal pyramid. And in order to draw the net, I'm going to start by drawing my pentagon base. And then each base edge gets a triangle. Lastly, in C, my base is a triangle. So this is a triangular pyramid. So I'm going to draw my triangle base, and then triangles for each base edge. Let's try a problem now finding the lateral area and surface area for a pyramid. I'm going to start by drawing the net of this square pyramid. So I have my square in the middle. That is 10 feet by 10 feet. And then I have a triangle for each base edge. And because this is a square, all of these triangles will be congruent. So when I find the lateral area, I'm going to find the area of all my triangles. And for surface area, it will be everything. So let's start by finding the area of just one triangle. I know the base edge is 10 feet, but if you look at the picture, I have no idea what my slant height is, my L. Something that we can use though is the fact that this height in the middle makes a right angle, and I have a right triangle in there, where I know one of the legs is 12, and notice how the other leg is half of the base edge. So half of 10 would be 5. And then, because this is a right triangle, I can use the Pythagorean theorem to find my slant height. So 5 squared plus 12 squared equals L squared. 5 squared is 25. 12 squared is 144, equal to L squared. 25 plus 144 is 169. And to get rid of a square, we square root both sides, giving me that my slant height is 13. And this tells me that the height of each of my lateral faces is 13 feet. So with this piece of information, I am now ready to find the area of my triangles. To find the area of a triangle, I do base times height divided by 2. 10 times 13 is 130. Divided by 2 is 65. But remember, this is just one triangle out of 4. And because this is a square base, all my triangles are congruent. So in order to find the entire lateral area, all I have to do is 65 times 4. And this gives me a lateral area of 260 feet squared. To find surface area now, all I have to do is add my lateral area to the area of my base. To find the area of my base, because it's a square, all I have to do is base times height. So 10 times 10 gives me an area of 100 for my base. So surface area is 260 plus 100, which gives me a surface area of 360 feet squared. So once again, the process of finding lateral area and surface area is not much different for pyramids. The only thing that's slightly different is that pyramids only have one base. So there's only one measure that we're excluding from lateral area that is included in the surface area. Let's try this one more time. In B, they did not give us a picture, but they did tell us I have a hexagonal pyramid. So I'm going to attempt to draw a hexagon. And for each base edge, I have a triangle. It says the base edge is 8 and the slant height is 12, which means the height of each of my triangles is 12 centimeters. So if I'm going to find the lateral area, I'm going to find the area of just one triangle and multiply by how many there are, because the problem didn't mention, but it's supposed to say this is a regular hexagon base, which would mean that all of these triangles are congruent. So to find lateral area, I'm going to do base times height, divided by 2 for my triangles. 8 times 12 is 96, divided by 2 is 48. But this is just one of 6 triangles, so multiplying by 6 gives me a lateral area of 288 centimeters squared. To find surface area now, I need to find the area of my hexagon, which remember is a little tricky. It involves me splitting up my hexagon into triangles, and I'll use a different color so that we don't get confused with our lateral faces. I'm going to find the area of just one of these triangles and then multiply by 6 to get the entire base area. I know that my base edge is 8, which means that this section is 4, and I'm missing my height. To find my height, I first have to find this angle, which I do by dividing 360 by 6, since I have 6 triangles, and I get 60 degrees. But then I'm going to divide that by 2 to get only half of it, so I know my angle is 30 degrees. I am now going to label my opposite adjacent hypotenuse. So across from 30 is my opposite. Across from the right angle is hypotenuse, which leaves my height as adjacent. It looks like the two sides I want to work with are my opposite and adjacent. So looking for opposite and adjacent, it looks like I'll be working with tangent. So tangent of 30 is equal to O over A, which will be 4 over H. I'm going to go ahead and cross multiply to get that 4 is equal to H times the tangent of 30. And to get H by itself, I need to divide by the tangent of 30. Which gives me a height of each triangle of 6.93 centimeters. With this, I am ready to find the area of each triangle. So I have my base, which is 8, times my height, 6.93, divided by 2. And then remember, since this is only one triangle, I need to multiply this by 6 to get the area of my entire hexagon. which will be 166.32 centimeters squared. And now that I have the area of my base, I can add this to my lateral area to get surface area. So surface area is equal to my lateral area, the 288, plus the area of my base, 166.32, which gives me a surface area of 454.32 centimeters squared. I hope you feel comfortable with finding lateral area and surface area because it's the same idea as with prisms, except with pyramids we only have one base to work with and all of our lateral faces are triangles. So make sure you are familiar with the area formula for a triangle, which is base times height divided by 2, and you should be just fine. Please let me know if you have any questions and I will see you in class.